Good afternoon, Year 8. It's a beautiful Sunday evening. Clearly, it's time for mathematics. So, in recent lessons we've been talking about area, two-dimensional surface. This thing here was probably sold as having an area of a certain size. Whiteboards, tiles, carpets, walls, all sorts of things we can use area in. And you want to use area because you don't want to order too much or too little paint or tiles or anything else you're looking at. Now in class recently, we've been looking at a number of different objects. We looked at a square, so that was one of these things. All sides the same length. We looked at rectangles, two sides being different lengths. We looked at triangles. We looked at parallelograms. Basically rectangles on their side. We looked at rhombuses, which were squares on their side. We looked at kites. Two sides the same length. And we also looked at trapeziums. They had the biggest and scariest looking formula, if you remember. Each one of these had a formula. We went through a careful process of writing down the formula, putting our values in it, and getting the answer out. Very important process to follow. Today, we're expanding it with one more object, and that is our friend, the circle. We are also going to look at things called semicircles and quadrants, which are parts of a circle. The formula is very similar to the circle. So, from the start, let's say we tried to draw a circle. Now this is where it all goes bad, because drawing a circle freehand is really hard. You try drawing it on the board. Yeah, it doesn't look very good, but you know, you're gonna have to take it tonight, I'm afraid. Now, if I tried to make that about 10 centimeters across, by the way, so in real life, that's about 10 centimeters. And if all of a sudden I asked you, what area is there, what amount of surface, it's not too easy to work out. Like, if you tried to draw a little 1 centimeter by 1 centimeter blocks here, remember 1 centimeter by 1 centimeter, see that there? That little block is 1 centimeter squared because its dimensions are about 1 centimeter by 1 centimeter. If I went and drew a whole heap of boxes on there, it's going to get very confusing because there's all sorts of curvy things going on here. It's definitely not as cooperative as these things. With a square or a rectangle, we could draw little 1 centimeter units and be able to sort of count up what the area is. With something like this, it's not so simple. But thankfully, there is our good friend pi. We have discussed pi before. Pi is a special number that we use, an irrational number that we use when we come to circles. It can help us find the distance around the circles. And it can also help us find the area, the amount of surface within the circle. The formula when it comes to area, and we're going to do nice examples of this for you soon, looks like this. The area is pi r squared. Do you remember what r is? Maybe? All right. From the center of a circle, from the center to the outside, that there is r. R stands for the radius. So from the center to anywhere on the outside, that's the radius. You may also remember the term diameter. It's not in this formula, but I'll point it out while we're here. Remember the line from one end to the other going through the center is D for diameter. But today we are focusing on radius because to find the area of a circle, the formula has radius in it. Now notice that that's the radius squared. What does squaring do? If I asked you what 6 squared is, what's that? Please don't say 12. 6 squared means 6 times 6, right? When you square a number, you multiply it by itself. So it's really the same as saying that's the radius times the radius there, not 2 times the radius, very different. So the formula states area is pi times the radius, or as we write it here, pi times the radius squared. Now, I'm going to magically make all this disappear, and then we're going to do some examples. And magically, we're back. So I'm going to do two examples of finding area of a circle here. All right, the first one here, notice that we've got a measurement from the center of the circle to the outside. In this one, they've given us R. They've given us the radius. So first thing you do when you find the area of any object is you write the formula. So for area of a circle, it's A equals pi r squared. Second step, as we always did, is we put the values in the formula. So remember, where there's no symbol, it means multiplication. So pi times the radius, which is 7, squared. From there, you can put it straight in your calculator. I'm afraid I don't have your exact calculator on me, as I wasn't planning on doing this on a Sunday night for some reason. So you're going to have to tolerate this really, really cool model here. This is actually the coolest scientific calculator I've got. It's a Japanese model called an FXJP 900. It's really beautiful. Unfortunately, the ones we get are a bit, they're not as great as this in Australia, and it's very sad. It definitely leaves my heart cold, and I hope you too will be all right, even though you've seen a really cool calculator and yours isn't as cool. But anyway, here we go, guys. So I'm going to go and put pi in. Thankfully, putting pi in is very similar on your calculators. I'm going to go Shift, and that times 10x button right down here, that's where it normally sits on the Casios. If you don't have a Casio, you are very, very naughty and not doing yourself any favors. Make sure to have your Casio scientific calculator. Multiplied by 7. You see the x squared button? You've got an x squared button too. That'll make a little 7 squared there. Very cool. Press equals, and you'll get something like that. I'm going to round to the second decimal place, which means it's going to go up to a 4. Remember, you look at the third place there. 5 or more, add 1 more. 4 or less, let it rest. So this is one where it goes up. That 3 is going to go up to a 4. So I get 153.94. Remember our units? There's a mark purely for our units. Meters squared. So units are squared, all right? So think 1 meter squared is like 1 meter by 1 meter. 153 lots of those, or nearly 154 lots of them. If I was ordering things, yeah, you'd probably order a bit more than that, because it's going to be really awkward getting those curves right if you're trying to tile a circle or something like that. Not a pleasant job, I have to say. Anyway, let's look at our second example. So that's our first example. The second example is a little bit different. In this one, I've been mean. I haven't given you the radius. I've given you the diameter, right? So this time we've got the diameter. The diameter is 10 centimeters. But if we know the diameter, we also know the radius. How are they related? We discussed this the other day. The radius is half of the diameter. So what's half of 10? 5. So in this case, the radius is 5 centimeters. So we know the radius now. I needed to know the radius because the formula has the radius in it. So let's now do as we would normally do, like we did over here. First, we write the formula. A equals pi r squared. Secondly, we put in the values. So it's going to be pi times 5 squared. Of course, I put in the radius there, not the diameter. At that point, I can put it into this beautiful device again. Again, I use the pi button in the calculator. I do that because it's more accurate than just writing in a value for pi. Times 5, and I press the x squared button to get the 5 squared. And you'll get a value something like that. So it's equal to 78.54. And remember our units, this time it was centimeters. So we're going to get centimeters squared. Now, I'm only going to complicate this very slightly from here. Sometimes you'll get half a circle and be asked the area of it. So let's say you were given something like this. That's trying to be half a circle. Not the best drawing I've ever done. Again, it's something like 9 o'clock on a Sunday night, so, take what you get. I'm going to draw in the radius here. I'm going to make the radius, 1.5 kilometers. Now, how do you think I'm going to work out the area of half a circle? How much surface is in half a circle compared to a full circle? Half, right? So what we do to the formula is we write the area here is going to be half of pi r squared. So it basically says the amount of surface in half a circle is half the surface of a full circle. It makes sense. So all you do if you have half a circle is put half in front of the formula. So I'm going to do that. In our case, 1/2 times pi times 1.5 squared. If I wanted to be really technical, by the way, I should use wavy equal signs here because we're always doing some sort of approximation. Whenever pi is involved, you end up having a bit of an approximation if you put a number at the end there. So if I put that in my calculator, I go 1/2. I put that in as a fraction. You could have also put that in as 0.5 if you want. You don't have to put it in that way. Times pi using the calculator's pi value times 1.5 and the x squared button equals s to d. There we go. And we've got 3.53 rounded there. So 3.53 kilometers squared. So that there, of course, that half a circle, I'm not sure if I gave you the technical word for this. A half a circle is called a semicircle. And the last thing I'm going to do for you is a quarter of a circle. And a quarter of a circle is called a quadrant. So I'm going to try and draw that. Something like that. You could also note that there's going to be a right angle in there. There's going to be a 90-degree angle. So what are we going to do there? I might call it 3.2 millimeters. There you go. Really, really small example. Now again, if a semicircle, the formula is half of the full circle. If you've got a quarter of a circle, you may well point out, well, the formula is going to be 1/4 of the full circle. And that would be correct. So this time when I write the formula, it's 1/4 of our normal area formula because the surface in 1/4 is, well, 1/4 of a full circle. So I write that. I write A equals 1/4 pi r squared. In the next line, I put the values in as we've always done. So it'll be 1/4 times pi times r is 3.2 squared. I'll do the approximately equal there. Put that in my calculator. So 1, make it a fraction. I use the fraction button there, that one there. Quarter times pi times 3.2 squared equals, and there we go. I've got rounded, it's rounding down there. I've got 8.04 millimeters squared. So that's a very small amount. In real life, that's going to be, something like that. A couple of millimeters by a couple of millimeters. All right. Oh no, you can't see my working at the bottom there. That's okay. You're only missing the 8.04 millimeters squared line at the bottom there. All right, I'm going to magically do something and be back in a sec. Welcome back. And with that, it's time for you to get some practice. So have a go at exercise 4E, page 206. The recommended questions here, 3, 5, 6, 7, 9, 10, and 11. Bye.